Hey everybody, I'm MathD. I wanted to make a video with a few more examples with linear equations for class A. So here's just a few more examples that will help you along with some of the homework questions if you get stuck. So here's the first one. The equation is -35 equal to 7 times parentheses 4x plus 3. And for a lot of these problems, there's actually a couple different ways you could go. Normally what I would do, if I wasn't really paying attention to the fact that this was the 7, this was 35, is I would just multiply or distribute the 7 through on the right-hand side. So one way to go is to say, -35 equals 7 times 4x is 28x, and 7 times 3 is 21. I'm just distributing that 7 to each of the terms there. And then I can collect all my x's on one side. I already have all my x's on the right, so I'm just going to subtract 21 from both sides. So I can use a different colored pen for that. So let's see. Negative 21 minus 21 is 0. So I get 28x on the right. And -35 minus 21, it's like 35 plus 21, but negative. So that's going to be, what, 56? So -56. And then divide both sides by 28. So -56 divided by 28 is equal to x. But -56 divided by 28 is -2. So that's -2 equal to x. Another way to solve this would have been to notice that 35 is a multiple of 7. So we could have started by dividing both sides by 7. So we could have said -35 divided by 7 is equal to 7 times 4x plus 3 divided by 7. 7 divided by 7 is 1. 35 divided by 7 is 5. So that's going to be a -5 on the left equal to 4x plus 3. Subtract 3 from both sides. -5 minus 3 is -8 equals 4x. Divide both sides by 2. -8 divided by 4 is, sorry, divide both sides by 4. -8 divided by 4 is -2, is x. Sorry, is x, which is then -2 is equal to x. Getting a little ahead of myself there. So I'll say, if this had happened to be an 8 instead of a 7, then this left side would have worked out the same, but we would have gotten like a less nice answer, probably a fraction. But here, since 35 happened to be divisible by 7, we can kind of take a shortcut. But I would say generally, this first way is the way you want to try and solve linear equations like this, because you're not guaranteed to have 35 be divisible by this number here. Let's do this next equation. 6 times y plus 1 plus 4 equals -14. So I would start by distributing the 6. So 6 times y is just 6y, and 6 times 1 is just 6. Plus 4 equals -14. And I'm going to add these together on the side. So 6y plus 10 equals -14. And subtract 10 from both sides. 6y equals -14 minus 10. When you have a negative number, oh, sorry, you can't quite see that. When you have a negative number minus another number, it's going to get more negative. So it's kind of like having 14 plus 10. In fact, if you really wanted to, you can write this as 16y equals negative, and factor it out, 1 times 14 plus 10. Oh yeah, that's 24. So 6y equals -24. So y is equal to -24 divided by 6. So y is equal to -4. I'll have to be very mindful of staying on screen here. All right, a few more problems. Here's another one. -4 times 5t minus 1 equals 3 times 2 minus 7t plus 6 plus t. So here we're just going to multiply or distribute things out. So -4 times 5t is -20t. -4 times -1 is plus 4. On the right-hand side, we have 3 times 2 is 6. 3 times -7t is -21t. And then here, I didn't run any parentheses here. I just have a plus 6 plus t. So let's see here. I have -20t plus 4 equal to 6 plus 6 is 12. And -21t plus t is -20t. And then I noticed something. I have the same amount of t on each side. So if I add 20t to both sides, they're both going to kind of cancel out. So I end up getting 4 equal to 12. Or you can subtract 4 from both sides and get 0 equal to 8. But the problem is 4 equal to 12 or 0 equal to 8 isn't true. So since this thing I'm left with, since all the t's, all the variables canceled out or went away, and I'm left with an equation that isn't true, it means that no matter what I would pick for t up here, the equation wouldn't be true. This equation has no solution. No solutions. On the other hand, if I would have got to the like 0 equals 0 or 6 equals 6 or 5 equals 5, it means every choice of t is a solution. So then every real number is a solution. We can actually even check further if you want. If you plug in a real number for t, say like t equal to 2, you'll see that this equation isn't true. In fact, let's do it. So if I plug in t equal to 2, then I know it's not going to work. I'm going to get -4 times 5 times 2 is 10. 10 minus 1 is 9, equal to 3 times 7 times 2 is 14. 2 minus 14 is -12. And then over here I get 6 plus 2. So I get -36 equals -36 plus 8. And if I add 36 to both sides, I get 0 equal to 0 plus 8. Just like if I had subtracted from both sides here. So that's not true. So we get no solutions. And here we see, for example, that t equal to 2 isn't a solution. But you don't have to check this. I just wanted to show you. All right. Sometimes your linear equations will have fractions. And although you could use fractions, or you could totally distribute the 3/4 here, right? This is like 9/4 x plus 18/4 plus 5 plus, whatever over here. That's not the easiest way to go. The easier thing to do when you're multiplied by fractional constants is to multiply both sides by a common denominator of this fraction. So let's see, 3/4 and 1/6, 4 and 6 both have 12 as a least common multiple. So I'm going to multiply both sides by 12. So I'm going to have this 12 times 3/4 times 3x plus 6 plus 5 equal to, this pen also seems like it's saying, 12 times 1/6 times 4x minus 2 plus 7. So it's a little messy there. So let's see. So now we're going to distribute. So the 12 distributes to the first term, which is 3/4 times 3x plus 6. And the whole point of this is that when you multiply three things together, you kind of pick any two of them to multiply first. I'm going to multiply 12 times 3/4. 12 times 3/4 is 36/4, but really what I should do is I should cancel one of the 4s or divide one of the 4s. So 12 times 3/4, I'm just going to write that. So 12 times 3/4 times 3x plus 6, plus the 12 also has to multiply the 5. So we're distributing this 12 across addition, equal to 12 times 1/6 times 4x minus 2 times 12 times, sorry, plus 12 times 7. So then the whole point here is that the 12 times 3/4, well, 12 is really 4 times 3. So this 12 and this 4, we can think of those as dividing, and 12 divided by 4 is 3. So I'm left with a 3 times 3, or 9. Also, 3/4 of 12, or 3/4 of 12, is equal to 9. 1/4 of 12 is 3, 2/4 is 6, or 1/2. 3/4 is 9. Here we have 12 times 1/6. Again, 12 divided by 6 is going to give us a 2. So I have 2 times 1, which is 2. So now I can say I have a 3 times 3 here, which is a 9. They'll still distribute to this 3x plus 6, because there's addition there to distribute across. Plus 12 times 5 is 60, equal to, that's a 2 now, which I'll distribute across the 4x minus 2. And 12 times 7 is 84. And if that was an even number right there, I could divide both sides by 2 to make it a little easier, but it's not what I'm going to distribute. 9 times 3x is 27x. 9 times 6 is 54. Plus 60, equal to 2 times 4x is 8x. 2 times -2 is -4, plus 84. So let's see, I have to combine all my x's together. So I probably subtract x over here and say I have 27x minus 8x. That's going to give me a 19x. I'm just going to add these together and get plus, let's see, 50 plus 60 is 110, so 114, equal to -4 plus 84 is 80. Subtract 114. So I'm going to get 19x equal to 80 minus 114. So 114 minus 80 would be 34. So 80 minus 114 is negative 34. So when you subtract things in like the wrong order, you're going to get a negative number. But the way you find it is you just subtract them in the easier order, the bigger minus the smaller, and then it's the negative of that. So this is 19x equal to negative 34. So that means we're going to get x equal to negative 34 divided by 19. One more page. Just a few examples to be helpful. This example, number 5 here, has the same idea as the previous one, it's just a little harder to see it. Or maybe not, actually. So 0.4 minus 0.3 times parentheses 5 minus 4x equal to 0.9x minus 0.7. A few things to point out here. One, all of these decimals are really fractions with a denominator of 10, right? This is 4/10, that's 3/10, that's 9/10, that's 7/10. But you don't even have to know that you can multiply both sides of this equation by 10 to get rid of those decimals. So watch. 10 times 0.4 minus 0.3 times 5 minus 4x equals to 10 times 0.9 x minus 0.7. Now, before I continue, I want to point something out here. Something we cannot do is say that 0.9x minus 0.7 is equal to 0.2 or 0.2x. Because sure, 0.9 minus 0.7 is equal to 0.2, but 0.9 times x is not the same thing, and so we can't subtract those because the 0.9 is the coefficient of x and the 0.7 is just a constant. Same deal here. The 0.4 minus 0.3 we can't do first because we have to follow the order of operations, which says you have to do multiplication before you do any subtraction. So we have to like distribute the 0.3 before we can start subtracting stuff here. The same idea is what you hear, right? The 0.9 multiplies this x before you can do any subtracting, so we can't really simplify this in any way yet. So, but now we're going to multiply everything by 10 just to make life easier. 10 times 0.4 is 4. 10 times 0.3 is 3. Some of you might be asking inside your heads, why isn't the 10 also multiplying the 5 minus 4x? Well, it is. It's 10 times 0.3 times 5 minus 4x. And when you have three things multiplied together, you have to pick which ones you want to multiply together first. It's kind of like if you had 2 times 3 times 5. You could either think of this as first 2 times, well, 3 times 5 is 15, and then 2 times 15 is 30. Or you can do the 2 times 3 first and say it's going to be 2 times 3 is 6, and 6 times 5 is 30. But what you can't do is you can't say the 2 distributes, because if you try to do that, look what happens. If you try distributing the 2 to each term, you're actually multiplying by an extra 2. You're going to say, I'm going to say it's not equal to 2 times 3 times 2 times 5, right? We cannot distribute across multiplication like that. For multiplication. Multiplication distributes across addition. Exponents distribute across multiplication like we saw in class today. So, right, this would be 2 times 3, which is 6. And 2 times 5 is 10. That would be 60, right? Oh, look, that's double as large as it should be. It should be equal to 30, but since we distributed the 2 incorrectly, we got an extra 2 multiple in there and got a 60. So when you have a number multiplied by a product, you just have to pick which of those parts you want to multiply it by. And I picked the part that made sense. 10 times 0.3 is equal to just 3. Same thing on the right-hand side. 10 times 0.9x, it's not 10 times 0.9 and 10 times x, it's just 10 times one of them. I'm going to say that 10 times 0.9 is 9, and then we still have to multiply by x. Similarly, 10 times 0.7 is 7. And now this is much easier to deal with. I would distribute, actually, I'm going to distribute the negative 3 to each of these terms. So it's going to be a 4 minus 15, and a minus 3 times minus 4 is, I should say, a minus 3 times a negative 4x is a plus 12x equals 9x minus 7. I have x's and not x's. Usually I collect the x's on one side, the not on the other. And if I have a choice, I'm going to try and collect the x's on the side that gives them the positive coefficient. So I'm going to subtract 3x from both sides to get, let's see, 4 minus 15 is negative 11 plus 9x equal to negative 7. And I'm going to add 11 to both sides so that 9x is equal to negative 7 plus 11, which is positive 4. So that means x is equal to 4 divided by 9. All right, last one here. So this problem has something in common with problem, what was it? Problem 4, where we have fractions. We're going to multiply by the common denominator first. Here, the common denominator, or I should say the least common denominator, is 4. So it's going to multiply both sides by 4. This is going to be 4 times 3/4 times 8x plus 12 plus 2 equal to 4 times 1/2 times 12x plus 10 plus 6. Distribute. So again, the 4 times this first part, I'm going to actually multiply it by the 3/4 and say that 4 times 3/4 is just 3. So that first part becomes 3 times 8x plus 12. I still have to distribute the 4 to the second term here. That's going to be a 4 times 2, which is 8. On the right-hand side, I'm going to get 4 times 1/2 times 12x plus 10. But 4 times 1/2 is 1/2 of 4, which is 2. So when I distribute the first term here, I get 2 times 12x plus 10. Over here, 4 times 6 is 24. Okay, keep going. So I'm going to distribute here. 3 times 8x is 24x. 3 times 12 is 36. On the right-hand side, I get 2 times 12x, which is 24x. 2 times 10, which is 20, plus 44. I can see that the 24x's are going to cancel out, or if I subtract the 24x from both sides, I'm left with no x's. And then 36 plus 8 is 44, equal to 20 plus, that's a 24 there, sorry, is 44. Or you could subtract 44 from both sides and say 0 equals 0, which is true. So what this means, unlike the problem, which was the problem 3, where we got no solutions because we got 0 equal to 8 or 4 equal to 12, here when you get 0 equal to 0, it means any choice of x would have been the solution. So here our solutions are all real numbers, are solutions. If you want, we can check. If we substitute any number in for x, like say x equal to, I don't know, try to pick something that's not terrible here. Sure, let's say x equal to 2. If x is equal to 2, then my equation becomes 3/4 times 2 times 8 is 16. Oh, I can't say this. Sorry, 1 second. Roll out here. Let's see. 2 times 8 is 16. So I've got 16 plus 12 plus 2. I'm looking up here. Apologies. Equals 1/2 times 12 times 2 is 24 plus 10 plus 6. And here, since my numbers are all even, I can actually deal with this relatively nicely. 16 plus 12 is 28. 28 divided by 4 is 7. So it's with a 3 times 7 plus 2 equals 24 plus 10 is 34. 1/2 times 34 is 17 plus 6. And look, it works out. 3 times 7 is 21. 20 plus 2 is 23. Equals 17 plus 6 is 23. And it would have been true no matter what value for x we picked because all real numbers are solutions here. All right, that's just a few examples of solving linear equations that I thought would be helpful to you all on your homework. See you tomorrow.